Okay, we start with the DC to DC converter. Very simple way of understanding is that if we give a DC supply like this to a load, now we can simply connect a switch over here, and this switch is allowed to turn on for some time, and this switch is turned off for some time. In this situation, the output voltage will be look like this. Let us say the input voltage is here Vs and output voltage here is V0. Since we are giving a DC supply, this supply voltage is a constant voltage of Vs. So here we are getting a constant voltage like this. The input voltage with reference to the time, with respect to time, the value is Vs and the magnitude is here capital Vs. The output voltage when the switch is on is obviously will get reflect the output voltage is same as Vs. After that it will be 0 and again it will be then again it will go on like this. So what is the thing is that it start from 0, the output voltage is Vs and the it is on for some time, that is say uh, k of times of t and total time period is t. If I talk that this is a total time period capital T, so let it be on for kt and rest of the time it is off, so the output voltage will look like this. Now we can achieve the DC like this. What is the drawback of achieving a DC like this? Or a drawback टा कौन होगा? यदि हमें DC टा एमती नवा किसी फाइल लॉस होचे. So if we get a DC like this, let me zoom it. Try to zoom it up. Just a minute. Just a minute. Okay. Okay. Now, what is the average voltage for such kind of output voltage? What will be the average voltage? We know the value of the average voltage is given by V average is equals to 1 by T integration of 0 to T V0 T dt, correct? This is a formula of average voltage. One can write also average voltage is equal to VDC and here 1 by T total time period and it is on for 0 to kt, rest of the time this is off and this value is Vs dt. So obviously this is equal to Vs times of kt by t and that is equals to k times of Vs. So that means the average voltage is here. Finally we get the value of the output voltage is equal to, or the average voltage is equal to k times of Vs. So if k is 0.5, output voltage is half. If k is 0.25, the output voltage is 1/4. Like that we can decrease the output voltage. Okay, great. This is the achievement. If somebody is asking you that what will be the RMS voltage for such kind of thing, how to find the RMS voltage? Okay, the RMS voltage, what is the formula? For the RMS voltage, again we have the formula. What is that? VRMS is equals to 1 by T integration of 0 to T V0 square t and integration with time dt. So we can write V RMS square is equal to this much. This is the RMS formula. So we can write down here, this is equals to 1 by t integration of 0 to kt, because it is on for the k of times and rest of the time it is 0. So this will be equals to Vs square dt. So obviously if I integrate that, it will become as Vs square by t times of kt, and this will be equals to k times of Vs square is equal to Vrms square. So from this, what is the relation we get? The output voltage V0, which is the RMS voltage. Here the output voltage is V0, and VDC is the DC voltage. So output voltage V0 is equal to root over of K times of Vs. So this is the two output we get. One is the output voltage and one is the RMS voltage. Let us say the K value is equals to, let us say the K value is equal to 0.5 and Vs is equal to 100 volt. So from this we can DC voltage is equal to 50 volts and RMS voltage is equal to 70.7. Root over of 1 by root 2, 0.707. So 70.7 volts. So this is how we are getting the output voltage, average voltage and RMS voltage. Now, this is not sufficient. If this is very good, then this could be used by many people. But the problem is here, if we want a pure DC, it must have pure DC current. Here the problem is the current is also like this. The current is on for some time, then the current is off. So we are getting a current on for some time, again the current is off, like that we are getting. And input current will obviously, this is input current is look like a step current. You see, the input also the current is like this. And whenever there is a step change in the current, it come across lot of harmonics. It will generate lot of harmonics. For that reason, we need to understand what are the harmonics for such kind of things. Okay, so let the screen be like that. We'll go for the new slide. What is how to find out the different harmonics in the waveforms? So what is a waveform is look like now? The waveform is here. This is the output voltage waveform. It's look like here the output voltage is straight line, then there is a 0, then for some time it is on, then it is 0, then sometime it is on, like that. And that what is sometime is equal to K of t, and this is total time t. This is the supply voltage Vs, output voltage is V0 t, and this is with respect to time t. With respect to time t, right? So we can write the Fourier series expression is equal to V0 t is equals to VDC plus summation of n is equal to 1 to infinity an cos n omega t plus bn sin n omega t. Okay, this is the Fourier series expression. In this Fourier series expression, there is a term called omega. Omega is what? Omega is the frequency. So here the frequency is time. So from here we can write omega is nothing but 2 pi by t, or this is the switching frequency, because when we are representing this output voltage, we are saying that the switch is on and off at a certain speed. This timing is what is the frequency, switching frequency of the switch. So Fs is usually 1050 hertz. 1050 hertz, that means in 1 second it is switching on and off at that speed, and this is nothing but 21 times of the 50 hertz. So we are switching at 21 times of the 50 hertz or 1000 hertz or 10,000 hertz. In that range, you are thinking of switching. Now, one can ask the question that why not you switch at 50 hertz? It's all right. If we switch at 50 hertz, then switching frequency Fs is equal to 50. Or if we switch at whatever, let us say Fs is a switching frequency. So similarly, I can write Ts. Or Ts is not so appropriate. So let us write it is as T. Omega is or omega S we can write later on we can write because omega S has got different symbol in the drive. So let us say this is omega for a time being. Okay. What is the formula of VDC? VDC is the average voltage whatever we get. So that is nothing but 1 by T 0 to T V0T dt. Similarly, what is the formula of AN? 1 by T by 2, that is 2 by T, integration of same 0 to T V0T cos n omega T dt, correct? And what is the formula of Vn? 2 by T, integration of 0 to T V0T sin n omega T dt, correct? Omega T will be there. And this value we have already found out. This value is what we need to find, right? Okay, let us find out this value. Okay, let us say an is equals to 2 by T integration of 0 to let us say kt, because after k T it is 0. And what is the output voltage? Vs. And let me write down once more. Okay, it's all right. Vs. And after that, cos of n omega T dt. So what is the integration of this one? 2 Vs by T. Integration of cos n omega T is sin n omega T. What is the constant term here? N into omega. Very good. N into omega. And limit is from 0 to kt. Correct? Limit will be 0 to kt. So if we expand this, what we'll get? 2 Vs by this n omega will let us bring in n omega T and sine of kt, sine of n omega kt. Rest of the term will be 0, so no need to write down. Okay, let us substitute this value of omega here. What is omega is equal to 2 pi by capital T. So if we substitute this value, we are getting this thing as 2 Vs by Tt cancel out 2 pi n. Correct? And this will be sine of n omega T. This is 2 pi by T we can write down here. So Tt cancel out 2 pi n into k. Can we write like that? 2 pi n into k? No. Yes, we can write like this. 2 pi n into k. So this term will be nothing but Vs by n pi sine of same 2 pi n into k. So we get the value of an finally, right? So here this is okay. Then can we go for the Bn, right? Okay, let us go for the Bn. So Bn is equal to again 2 by T integration of 0 to kt, same Vs sine n omega T, correct? And integration with respect to time Tt. Not to be confused with d omega t. If we have written d omega t, then this is 2 pi, that is also k times of 2 pi. We are writing in terms of rate time only. So this is 2 Vs by t. Integration of this is cos. It is cos n omega t divided by n omega and minus sign is there. So what we can do, we can switch the limits. And here we can write kt and this one is 0, right? Okay, and then we can just take this and this is we have already done this exercise. So vs by n pi, we can directly write vs by n pi, and that side we can write down as cos 0 is 1 minus cos of n omega k t. We can write like this, and this will be finalized as vs by n pi 1 minus cos of 2 pi n k. Can we write like this? So here we have got the value of bn. We also get the value of an, and also we know what is the value of vdc. If we substitute this value, what will be happen? Let us write down here. If I write down this values over here, this will be equals to k times of vs, and here will be summation of n is equal to 1 to infinity. An is equal to vs by n pi, and what is the vs by n pi? And sine 2 pi n k. Sine 2 pi n k into cos n omega t, then plus what is the value of bn is vs by n pi 1 minus cos 2 pi n k into, yes, sin n omega t. Okay, that much. Okay, let us put all these things in a. Okay, and this is nothing but v0 theta, v0 t is equal to this big line. What I will do is that this is we will convert into 2 sine of n pi k or pi n k, whatever you can write, pi n k, and cos of pi, okay, 2 sine 2 theta, 2 sine of n pi k cos of n pi k, and this one will be equals to 1 minus cos theta. 1 minus cos theta is 1 minus cos 2 theta, sin square theta, or 2 sin square n pi k. Can we write like this? Okay, so here will be the, okay, if we substitute this one, and we will write the same thing here, cos n omega t, and this side plus, and this side will be sin n omega t, and we will take this vs by n pi common. Summation of n is equal to 1 to infinity plus kvs, correct? Now from this we can take out the term vs by n pi, here 2 sin n pi k. This we can take common, right? Okay, and rest terms will be sin n pi k. Okay, we can write directly, no need to write down again and again. Sin a cos b plus cos a sin b. No, sorry, cos a cos b sin a sin b. So cos a cos b plus sin a sin b, what it will be? Cos a minus b. So we can write cos A minus B or B minus A, it doesn't matter. Cos, if you rotate also, it doesn't matter. Just I want to keep the omega t in the beginning. N pi k. Is it okay? So we get the formula finally, right? So this is the final formula of the V0 t. Without neglecting any terms, we get a very simple and good formula. Okay, let us now put the value of k equals to 0.5. Let k is equal to 0.5. In this situation, what is V0t? V0t when k is equal to 0.5 is equals to Vs by 2 plus this will be summation of n is equal to 1 to infinity Vs by n pi. This will be 2 sine n pi by 2 when k is equal to 1 by 2. This is that, and this side will be cos of omega t minus n pi by 2. I think this is the answer. If k is equal to 0.5, k is equal to 0.5, we get this value. Now let's find out the value for different values of n. So this thing is will rub, na? That is not required. Okay. So if we take the values of, let me just zoom this up, that's better, because this all will be there. Okay. So the same equation for different values of n. So n is equal to 1, there are the n is equal to 2, n is equal to 3, n is equal to, we'll do for 5, that's all. For n is equal to 1, we get, evaluate this term, we get Vs by 2 Vs by pi sine of pi by 2 cos of omega t minus pi by 2 for n is equal to 1. For n is equal to 2, obviously this will be 0, because reason is here it will be sine of 2 pi by 2. So 2 cancel out, sine pi is 0. And n is equal to 3, this is 2 Vs by 3 pi sine of 3 pi by 2 into cos of omega t minus 3 pi by 2. Okay. For 5, no need to go, it will be understood. This is okay. What is the value of sine pi by 2? This is 1, so neglected. What is the value of cos omega t minus pi by 2 in terms of sine? Cos theta in terms of sine. Sine of, if I write cos theta, so this is nothing but sine of theta plus 90 degree. Sine of theta plus 90 degree is same as cos theta. How? See that. Let us draw sine of theta plus 90. So it will start from minus 90. So when it will start from minus 90, it represents a cosine wave. Good. So we can rewrite this as, this is as 2 Vs by pi sine of omega t minus 90 plus 90, that is omega t. Done. For 2, n is equal to 2, this is 0. For n is equal to 3, this is how much? See, sine of 270 degree. Sine of 90 is 1, sine of 270 is minus 1. So this is minus 1, no doubt. But this is cos of omega t minus 270, minus 270 plus 90. That is sine of omega t minus 180. So just check in the rough, sine of omega t minus 180. It is same as minus of sine omega t. So that's why this minus and this minus will cancel out and you will get 2Vs by 3 pi sine of 3 omega t. I missed it here, this is cos of 3 omega t, and now it's because I think here we missed one thing. This is cos of n omega t, no? So n is a term over here, n omega t. So here also the term n is must be there. Cos of n omega t minus n pi by 2. So that's why you need to write here 3. So similarly for n is equal to 5, what is the equation? It will be nothing but 2Vs by 5 pi sine of 5 omega t. Clear? So finally we get us equations like this. Now after expanding this Fourier series, we got V0t is equal to kVs plus 2Vs by pi sine of omega t plus 2Vs by pi sine of 3 omega t plus 2Vs by pi. What is the mistake I have done? Yes? 3 pi, and this was 5 pi. Very good. So now we can rewrite this as kVs plus 2Vs by pi. This is in bracket sine omega t plus plus sine of 3 omega t, 1 by 3 sine of 3 omega t, 1 by 5 sine of 5 omega t plus dot 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 up to infinity. So if we proceed like this, what is the value of 2Vs by pi? Can you check in the calculator? 2 by pi is how much it is coming? One more thing, this 2 by 5 is the peak value of the fundamental waveform. So what is the value of 2 by pi? Imagine that Vs is equal to 100. Two by pi is, it is 2 by pi into 100. How much? So if Vs is 100, it is 63.66 volts. And since this is a peak value, what is the RMS value? By root 2. How much it is? 63.66 divided by root 2. Okay, we get a 45.014. We can write simply into root 2 that much of sine omega t. We can also write like this. Same thing. Okay. This side will be same, but we can simply take it out and we can say 1 by 3 sine of 3 omega t, 1 by 5 sine of 5 omega t, and like that. We can proceed this way. Okay. And this side is how much? If we take this as 100, this is equal to 50. So 50 plus this, all those things we get. Let us do some analysis out of it, because simply doing this doesn't have any sense. Let us do some analysis out of it. Analysis is that if the waveform is like this, What is the RMS value we find? If the voltage is 100 volts, what is the RMS value we find? 70.7 volts, nearly. Okay. So if we take the RMS voltage of this one, same, it should be same. Like if this is a V0T, if the RMS voltage calculating directly is like this, so RMS voltage of the entire thing is also should be like this. Okay. So RMS voltage of this DC term 50 will always be 50. Correct? Okay. RMS voltage of this is 45.014 fundamental. RMS value of the third harmonic is 45.014 divided by 3. So let me write 15, roughly 15, right? Okay, 15. And RMS voltage of the fifth harmonic will be 45 divided by 5, nearly 9. And plus dot dot dot. Remember, we have to do the square. V0 square is equal to 50 square, this square, this square, and this square, and dot dot. Let us take this one only. So V0 is how much? Root over of 50 square plus 45.014 square plus 15 square plus 9 square. Find out how much this value. 50 square plus 45 point this square and this entire square root over. How much it is coming? 69.514. That's the value of V0. We have taken up to first, third and fifth harmonic. Suppose we add rest of the harmonics, what is the total value? What will be the total value if we add? It will be coming around 70.7. Now this is the value if we add third and fifth. Suppose somebody will ask you the question indirectly, what is the total RMS value if we add the DC component and the first, third and fifth component? So this is the answer. Or somebody can ask you that what will be the total harmonics excluding up to fifth harmonic. After fifth harmonic you add all the terms up to infinity and what is the value? So this value is 69 point this, 70.7 minus this one is the contribution of all these harmonics is coming around that much. Okay, so this is the rough idea about what we have done is correct, right? And this is the RMS value. So another thing is that what will be the frequency spectrum? So frequency spectrum will be given as what are the harmonics component present and DC outputs, sorry. So fundamental is, suppose this is 100. So the fundamental voltage which is available here is like this. This is the value of DC, VDC. And this is 0. 1, 2, 3, 4, 5. This is the different harmonics is there. And the fundamental one is coming around to be, if this is value is coming around 50, this one is coming around, here you will not write the RMS value because this represents the peak values of it. So peak values was how much? This is around 2 pm, 63.66. So this one is 63.66. And after that third. This is how much? No need to calculate. This is 63.66 divided by 3. This one is fifth. This is 63.66 divided by 5. Or you can write down this as 2 Vs by pi. Or 2 Vs by pi by 5 pi. Or 2 Vs by 3 pi. Like that we can write. And this is the harmonic spectrum of DC-DC converter. So what is the takeaway with this? Finally what we take away is that this is the switching frequency. If the switching frequency is 50 Hertz, so you are going to get this much of fundamental current in the output. That means if we do this output waveform is look like this, this frequency of T, this is switching frequency Ts, no, not switching, the switching frequency is Fs. The switching frequency Fs, if it is 50 Hertz, so you are going to get fundamental component in the output, which is very dangerous. But if you remove this one with 21 times of 50, what is the advantage? The first harmonic which is visible is, yes, the first harmonic which is visible will be very away from the actual line. The first harmonic will be visible far away from it, and this will be, we can write 21st. So the first harmonic will be out. So like that we can remove the harmonics from first, it will be converted into 21st, and 21st harmonic can be easily removed because high frequency we can have a small value of inductor to remove the harmonics. छोटिया इंडक्टर लगेले हम हार्मोनिक्स टा पळेबो. हाई फ्रिक्वेंसी को बाहर करे आप बड़ इंडक्टर साइज ऑफ द टेबल, बट जेते जेते फ्रिक्वेंसी अधिका हबो छोटो रेजिस्ट इंडक्टर लगे देले भी सेटा बायपास हे जिवो. So this is okay for DC-DC convert, and that is the answer to the question why you prefer higher frequency. But somebody will say, okay, we will go for megahertz. What is the answer? If you go for megahertz, remember that when you are switching on from 100 volt to the 0 volts, 100 volt to 0 volt, there is a rate of change dV by dt. High rate dV by dt will create a EMI effect, electromagnetic wave. So that will, if there is a high rate of change of voltage, what will happen? Wherever there is a capacitor, there will be a high current flowing through it. Similarly, if there is a high rate of change of current, like in the tube light, if you do the sparking, suddenly there is a short circuit, then open circuit. So there is a rate of change of current, dt is very high. If dt is high, the voltage across the inductor is high. If rate of change of voltage is high, the current through the capacitor will be very high. So those are the electromagnetic wave, because between you and me there is a capacitance, very high capacitance. But if there is somewhere high dV by dt, so it may impact you because of me. So that is why high rate of change of voltage is not allowed. So that is the problem. So we are okay with 21 Hertz. If somebody say okay, we can go for 40 Hertz, because after 40 times of 50, sorry, not 40 Hertz, 40th time of 50. So it is 40th Hertz, sorry, 40th order. 40th order is very easy. 39th order के बाद तो उसका value बहुत कम हो जाता है. It is out. So no need to go for that. So this is how we will complete, right? Okay, next. Next is that this is a question. Problem is this one. Let us understand the problem, then we will solve it. Problem is that whenever you have suppose a DC circuit like this, just a minute. Suppose we have a DC circuit same. Okay. We get a DC voltage here. And again we use a switch, and this time switching frequency is taken care of, and we call this a chopper. ये जो switch टाको कहते हैं chopper. We connect a RLE load, RLE. So we connect RLE load with this. So whenever there is a RLE load, obviously you need to have a freewheeling diode, and you get a freewheeling diode out of it. Okay. So in this kind of circuit, what is the supply voltage? Vs. What is the output voltage? V0. V0 means small v0. It is the unidirectional voltage, but it is changing. But when we write VDC, VDC is the DC voltage. That is not changing, it's a fixed value. And this is E, this is L, and that one is R. And this diode is a D, right? Okay. So what is the voltage, output voltage? V0t is equals to R into I. I is, you can say I0, or you can simply write I, plus L d I0 by dt plus E. During what time? During the time from 0 to t to k times of t. During this time, this is a voltage equation. K times of t means during the on time, or we can say on time. On time. When the switch is on, then the volt. This is by using the KVL. This is the equation, and this is nothing but. Let me just write. This is V0t is equals to Vs is equal to this much. So we are getting the equation like this. Okay. Okay. Better to do in this way, so that double equal to will not be confused. Now, what is the equation when this V0t in the off time? During the off time, the output voltage is, the supply voltage is 0. Okay, so supply voltage is 0, and the current in the secondary will be I into I0 plus L times of d I0 by dt plus E is equal to 0. So either we can write 0 here, or better to write on the other side also, it's okay. This was equal to 0. We can write like this. This one also we can. This is equal to Vs. Okay. So we are getting two equations for the on time and off time. Before going to the derivation, let us understand what is the objective, why we are doing all those exercise. Now see that. Let us see that what is the output graph will look like. Let us say I0t. How the output current will look like, and what will be the output voltage. Two things is coming into mind. What will be the output voltage and what will be the output current. This is for the off time. Yeah, this is, we can write 0 to, this is from kt t to capital T, and we can say off time. When the off time means switch is off. Okay. So what will be the output voltage? The output voltage will look like a straight line for the time kt, and rest of the time it is 0. So till time kt, the output voltage is there, and this value will be equals to Vs, and after that it is 0. So this is the value of output voltage. So we can draw a line like this, that this is the average voltage. This is the average voltage VDC. This is the average voltage VDC we get. But this is the output voltage, this is a yellow line, fine. How the output current will look like? So to get the output current, let us extend this dotted line. The output current will look like this. When the time this is on, so obviously the current will rise because Vs is connected across R, L is a inductor. Okay, one more thing, I was asking a question like, we connect a DC supply across the inductor. Inductor is a very short circuit, so it will draw very high current. But if you turn on for just for microsecond, short circuit is there, but the current will rise from 0 to certain value, then we off. Again it will come down from certain value to again 0. Because if we apply the voltage across inductor, DC voltage across inductor for a short time, टिक्के टाइम पे हम ऑन रखिया ताले शॉर्ट सर्किट होगा नहीं. So how the current will behave? The current will rise like this. The current will rise, after that the current will fall, and again the current will rise. So it will have a minimum current I1 and the maximum current, let us say, I2. Let us say it has got a minimum current of I1 and maximum current of I2. This is where we actually learn the concept of continuous conduction, just continuous conduction and discontinuous conduction. Now if the load is high, where I1 and I2 will be there. If load is, we decrease the load, then I1 will come down to 0 at certain time, and just continuous conduction. After that it will be a discontinuous conduction. So what will be the perfect load so that we can have a continuous conduction? That should be in our mind. So there the question is, another question is asked that if that is there, what is the current ripple? What will be the current ripple? The current ripple will be between this, and that is I2 minus I1, or we can say delta of I. Delta I is nothing but I2 minus I1. I2 minus I1, right? So in this way we have got a current ripple. Our objective is to find what is the value of I2, what is the value of I1, then what is the value of del I. This is the three objective of doing this derivation in terms of Vs, in terms of R, in terms of L, in terms of switching frequency. What are the variables available with us? Vs, R, L and switching frequency Fs, and E, obviously another term is E. So we have got 1, 2, 3, 4, 5. We have got 5 terms. We need to answer what is the value of the current I1, what is I2 and what is del I. Obviously when I1 and I2 is known, del I is known to us. We cannot do anything with the voltage. That is higher, we will later on we go. But for these things only I1, I2, okay. So this equation is there, we are going to solve it. So let's solve this equation first. That is R times of I am writing I only, L di by dt plus E is equals to V, and this is a differential equation, single order differential equation with a steady state value of steady state value is Vs minus E is the steady state value, right? So what is the equation of the current? The current of I of t is equals to A0 e to the power minus t by tau plus Vs minus E by R. How to write? Let me just rewrite once more this equation. We can rewrite this equation as I, better way, okay, di by dt L by R plus I is equal to Vs minus E by R. We can write like this. So this term is nothing but, we can have tau. Tau is equal to L by R. We can rewrite this, and this is the what is called particular integral. Another is complementary function. Okay, so that way we can try to solve, and we get this is a transient portion. Remember, the transient portion dies out after some time. So first initial value will dies out after time, certain time, that is why exponentially decay, e to the power minus t by tau. The steady state term will remain. Fine. So how to find the this A0 value at, so I of t at t equals to 0 is obviously not 0. We have assumed it as I1. We have assumed it as I1. I1 is equal to A0 e to the power minus, at time t equals to 0, this is nothing else. Find this is Vs minus E by R. So A0 is nothing but I1 minus Vs minus E by R. If we substitute this value here, so this will come out to be I1 e to the power minus t by tau, and let me write directly Vs minus E by R 1 minus e to the power minus t by tau. Correct? So final equation now is this, that we can write the final equation as I of t is equal to I1 e to the power minus t by tau plus Vs minus E by R 1 minus e to the power minus t by tau. This is what I was telling you, that the initial current will decay after some time and the final value will be there. This is we have learned in the drive class during learning that how the temperature is changing. Initial value of the temperature will decay and the final value of temperature will try to speed it up. But this is not the final, actually attained by the final value will be different. I2 will be different from this. Okay, this is the value of I1. Now if this is the value of I1, what is the value of the current at this time? What is the value of the current at this time? I2. And what is the time here? K times of t. So for at k times of t, we can write I is at the time of kt is equals to nothing but I2. At that time, what is the current? Instead of I1, it is I2. So I2 is equal to I1 e to the power minus t by tau plus Vs minus E by R 1 minus e to the power minus t by tau. Correct? Okay, let me write down this entire thing on a fresh page. So what we get finally, I2 is equal to I1 e to the power minus kt by tau minus kt by tau plus Vs minus E by R 1 minus e to the power minus kt by tau. Do you need to refer the previous one? Check it out. It is e to the power 8. This is the portion we just taken out on the other side. Here I have missed the term. This, instead of writing here t, I need to write here kt. kt. kt by tau. Because at time kt, we are getting output current as I2. So here we get this value of kt, right? So this is one portion done. This is the equation we get during the rise time. So I2 is equal to this. During the fall time, what was the equation? During the fall time, the equation was Ri plus, during this is off time, we can say off time. During off time, Ri L di by dt plus E is equal to 0. So this is very simple. So again we can write I is equal to A0 e to the power minus t by tau and plus minus E by R. I am writing again plus because to simplify, minus लिखने के बाद problem होगा क्योंकि उस equation में Vs को अगर आप 0 कर दोगे तो you will get the same thing. Correct? And this is, we can say we can give a different representation of like I2 and writing here as T2. We can write like this also. Just to simplify that this is a time when it is off time and you are actually, the current is rising like this. This is kt and this is t and this is the time T2. T2 is the time from kt to t and it is rising from, sorry, this is not the waveform. It is actually falling from this. This is the value of I2 and this is the value is I1. So we're getting this term like this and here, right? So what we can do, we can find the value of A0 from initial condition. So I2, what is the initial termination here? T is equal to KT. So what is the value we're getting? At time T is KT, this is I2 actually. So I2 is equal to A0 e to the power minus KT by tau plus minus E by R. So from that we can write A0 is equal to I0 plus E by R e to the power KT by tau. Correct? I0 plus E by R e to the power KT by tau. Sorry, A0 is equal to I2. So not I2. A0 is equal to I2 plus E by R into e to the power KT by tau. So after we substitute this value in this I2 equation, what we'll get? Let's remove this. We get here I2t is equal to A0 is I2 plus E by R into e to the power KT by tau e to the power minus T by tau minus E by R. Okay, it's minus E by R. So we can simplify this as I2 e to the power minus T minus K T by tau. Usually when we write an exponential term, we must write it in terms of a negative, otherwise it represents exponentially rising. So minus of T minus KT by tau, this is a time delay equation, nothing else. And what else? We can write plus minus E by R 1 minus e to the power same minus T minus KT by tau. Very close. So this is the steady state value. This is the steady state value we observed in the equation. Steady state value is minus E by R. So steady state value we have got 1 minus e to the power that much, and initial value decays with time. But only thing is that initial value somewhere did a mistake. Yeah, this is correct. The initial term is exponential decaying and the final term is exponential rising. Same thing whatever we get here. Only now next is that this is the equation of the I2. So at time t equals to I2 at time t equals to capital T. At time t equals to capital T means when this ends. At that time, what is the value of the current? The value of the current is I1. From I2 it will come down to I1. And then if you substitute the value of t equals to capital T, then this equation will look like I2 e to the power minus 1 minus k times of t by tau. I will write here plus minus e by r, same 1 minus e to the power minus 1 minus k t by tau. Simple. So we get an equation like this. You do it, then you will understand. This one is right here, I2, and this one is here 1. So we get two equations finally. So let us rewrite these two equations in a simple way with taking a constant. Just substitute the value of as a z. Z is equal to t by tau. Because the equation is looking very complex, that is why we have to use it as term z and rewrite the entire thing. I will write down everything here so that it will not be mistake. So let me just. Okay, so let me write down this term once again. So I2 is equal to I1 e to the power minus k times of z plus Vs minus e by r 1 minus e to the power kz. Correct? And the second equation is I1 is equal to I2 e to the power of minus 1 minus k times of z plus minus e by r 1 minus e to the power minus 1 minus k times of z. Is it correct? So we get two different equations here. Like this, another is here. Is it correctly copied? I1 is equal to I2 e to the power, yeah. So let me remove this one. And simply write down here. I2 value, let me substitute here. This is I1 e to the power minus kz plus Vs minus e by r 1 minus e to the power minus kz. This is the value of I1, correct? I2. Let us substitute this value, then write down the other values. What is the other value? E to the power minus 1 minus kz plus minus e by r 1 minus e to the minus 1 minus kz. Correct? Done. We'll do it. And this is what? This is I1. So I1 is equal to I2. We replace the value of I2 here, and rest of the things we keep as it is. Now the real work comes out. What is the value now? This and this. Remember to multiply this term and this term. E to the power minus kz, e to the power minus z plus e to the power kz. If we just do some rough work here, let me just do a rough work. E to the power minus kz into e to the power, this is minus z into e to the power kz. So this term will cancel. So we can write down this as I1 e to the power minus z, minus z, correct? Then this side we can write down easily. Vs minus e by r, this will be here e to the power minus 1 minus kz minus e to the power minus z, correct? And this will be minus e by r 1 minus e to the power minus z. This is okay? Just check. This is input is I1, left hand side. Now after this, the equation is going to be very, very simple. Nothing to do. Up to this is we have to just very carefully, because one way, if by mistake we miss something, so the entire equation is going to be wrong. Okay. Okay, now this is done. So let me keep it at the top. Now this can be written as I1 1 minus e to the power minus z. Done. And this side is nothing but Vs by R. You have got this equation, and this is the equation, e to the power minus. Can we split this one? E to the power minus z, e to the power minus z, e to the power kz, right? Minus e to the power minus z. That is the answer. And then we have plus of minus e by r. What will do? These two will add up. So when we add these two, this one and this one is opposite. So they will cancel. So 1 minus e to the power minus z. Simple. Cut it. Okay. Can we write down I1 is equals to Vs by R. Take out this e to the power minus z, e to the power kz minus 1 divided by 1 minus e to the power minus z minus e by r. Simple. The final equation is even more simple. If I remove this e to the power kz here, like means if I take it here, it will be equals to Vs by R e to the power kz minus 1 by e to the power z minus 1 minus e by r. How simple is the equation? The final equation is very simple. Yes, once we did the entire thing, finally we get I1 is equal to e to the power kz minus 1 by e to the power z minus 1. And this obviously the DC term, the back EMF is the negative term, so that will be remain as it is. That is the value of I1. Okay, I2 we will not derive, we will simply write the value of I2. E to the power minus z. This we taken it left. Then this minus z, if it will come down, it will be to z. E to the power z will be here, and this will be 1. So we can write similarly. No need to do the derivation again. Again, the wastage of time is. What we can do is we can simply write down the value of I2 again. Similarly, we can write I2 is equal to Vs by R e to the power minus kz minus 1 by e to the power minus z minus 1 minus e by r. This is I2, another is I1. Finally, we get these two values, right? Okay. If we get finally, can we just recall this in a fresh screen? Okay. So I2 is how much? Vs by R e to the power minus kz minus 1 by e to the power minus z minus 1 minus e by r. And what is the value of I2? Sorry, I1? Vs by R e to the power kz minus 1 by e to the power z minus 1 minus e by r. Very good. So we remember these two. What is the del I? I2 minus I1 is equal to, so obviously these terms, constant terms will be deleted, and what's remaining is Vs by R whole bracket e to the power minus kz minus 1 by e to the power minus z minus 1 negative minus of kz minus 1 by e to the power z minus 1. This is the finally we get, and that can also be simplified. At the bottom we need to keep 1 minus e to the power minus z. Just do some rough work here before we approach that. Can we write this lower term as 1 minus e to the power minus z by taking the term e to the power z common? So this will be look like this, e to the power z minus 1, right? So 1 minus e to the minus z, and upper it will be, obviously it will be changed. So this will be e to the power minus z on the top, correct? So e to the power minus z when multiply with e to the power kz minus 1. So this will be what? E to the power minus 1 minus k whole times of z minus e to the power minus z. Such kind of thing. Let us, this is a rough work on, yeah, okay. So let us rewrite this. So del I is equals to Vs by R. Just reverse both the things, 1 minus e to the minus kz by 1 minus e to the minus z minus 1 minus e to the minus z. ऊपर क्या हो जाएगा? That thing will be e to the minus z into that, right? So it is e to the power minus 1 minus k times of z minus of e to the power minus z. This much. But this is 1 and this side is 1. And let me just simplify and write down in a proper way at this side. This will be equals to Vs by R 1 minus e to the power minus z 1 minus e to the power minus kz minus e to the power minus 1 minus k times of z, then plus e to the power z. This is yes, it is minus z, right? Yeah, now it is correct. Now after doing this, we need to come down to a value of k, because after that we cannot proceed further unless we define the value of k. So once we define the value of k, after that we can go for the value. So if I will just adjust it here. Now if the value of k is equal to 0.5 again. If the value of k is equal to 0.5, then del I is equal to Vs by R 1 minus e to the power minus z by 2 minus e to the power minus z by 2 plus e to the power minus z, and the lower term will be 1 minus e to the minus z only. At what condition? When k is equal to 0.5. So yes, let us do the rough work here. This is nothing but 1 minus actually a square minus b square, a square plus b square minus 2ab. You have to write down in this formula. So यहाँ पर जो e to the power minus z by 2 actually 1 minus 1 plus this term e to the power minus z by 2 whole square, and this will be minus of 2 e to the power minus z by 2. So this is a square plus b square minus 2ab. So that will come as 1 minus e to the power minus z by 2. So what we will do, we will represent this entire thing as on the top 1 minus e to the power minus z by 2 whole square, and lower bottom is 1 minus e to the power minus z by 2 whole square. So finally what we'll get here after doing that, after doing this, we are going to get a very clear small simple equation, that is Vs by R, a minus b whole square, niche 1 minus cut it will delete it. So 1 minus e to the power minus z by 2 divided by 1 plus e to the power minus z by 2. So we can rewrite this as Vs by R e to the power minus z by 4 minus e to the power minus z by 4 divided by e to the power minus z by 4 plus e to the power minus z by 4. Can we rewrite like this, the same equation? E to the rough work let me do here. Like e to the power minus z by 2, can I write like e to the power minus z by 4 into e to the power minus z by 4? We can write. Then e to the power minus z by 4, let us say e to the power minus z by 4, I multiply both the sides on the top and the bottom. Then this is look like this, simple. Okay, this is a formula we are going to use here, that is called 10hx, e to the power x minus e to the power minus x by e to the power x plus e to the power minus x. This formula, hyperbola, 10hx. Now that thing is now easily recalled as Vs by R 10h. What is x? Z by 4. That's all. This is a hyperbolic 10h of x, which is nothing but, I will draw the curve for you. Okay. See, let us see the hyperbola once more, just in the recall in the +2, because this need to be recalled. Let us say this is 1 and this is say -1, correct? Now this is 0. If what is the value of here 10hx? Suppose it will go from like this. This is what represented by this is the representation of 10hx. 1, this is -1. This is -1, this is 1. So 10hx value is actually a sine function, so which varies from this 1 and -1, and it changes polarity. And what is the 10hx? 10 of hx is equal to e to the power x minus e to the power minus x by e to the power x plus e to the power minus x. This is the 10hx, it changes this value. So how much we get the value of del I? Del I is equal to Vs by R 10h Z. What is the value of Z? Okay, let me write Z by 4. So that much is equal to Vs by R 10H. Z value कितना? Z is equal to T by tau. So T by 4 tau. Correct? So I can write down this as 10H. What is the T? T is nothing but a frequency. T is a frequency. What is tau? L by R. So L by R and divide 4. So finally we get an equation like this. Now this is the x one. This is the value of variable called x. This is what x. Now you have to decrease the x. If you want to decrease the value of del I, you have to decrease the value of x below this value. You have to keep the value of x here between this range. More you close, this will be more closest. So it like this. So to decrease it, you can increase the frequency, decrease the value of R, so current will rise. Increase the value of inductance, obviously the del I will decrease, and obviously other things are same. So finally you get the derivation complete out, this one. So two things is covered. One is the Fourier series analysis of DC-DC converter. Another is how to determine the current ripple I2 and I1. So both are long type questions of 10 marks kind of things. Individually they are like 20 marks like that. 10 marks individually. Enough for today.